Hello, and welcome to this IBM CODE SF event, which is part one of a series of container orchestration events that'll be happening every week from now until July 10th on Tuesdays during this time frame. For those of you who are new to IBM CODE SF, we're a team of developer advocates from the IBM San Francisco Bay Area, and we host in-person and online meetups, lunch and learns, workshops, and other exciting events. So you can come meet cool subject matter experts and learn about cutting-edge open source technologies. I recognize a few people who are in the comments section who have been to our events, so welcome to you as well. So just a few community guidelines before we start. Let's keep the chat relevant to today's topic. And if you have any questions, please pose them in the Ask a Question section, which is right down at the bottom here. And upvote any questions you'd like to have answered, and our speaker will answer them at the end of the session. So without further ado, we have Mark Sadowski, an IBM CODE SF developer advocate, who will be presenting on Introduction to Containers. So take it away, Mark.
Hi, good evening, good morning, good day, everybody. This is Mark Sadowski from San Francisco. We are together today talking about containers, and I will share the screen with you. So let me try it here. Just a sec, and we will be sharing the screen. So I hope everybody's seeing the screen now. So it's intro to containers, and we will speak in following four sessions. This is the first one of four about containers and why we are doing that. So before we start, I would like to inspire you to take part in the call for code. So IBM, together with the Red Cross and United Nations, is offering you to take part in an event or hackathon, which delivering a code, a system, a solution for our common good. So if you think it's something that you can do, please visit the site developer.ibm.com/call4code, all small letters. You can find it on the right bottom corner, and we have an award for the best solution, and it's about $200,000 for the team that is going to do it. So without further ado, I will move forward to the next slide, but think about call for code. So our agenda is about containers, why we want to do it, and what are the technologies that are being used, how it started, and what do we have now for orchestrating larger systems, and what IBM is doing with containers. And we will speak a little bit about Istio, and we'll have summary at the end. But if you like one of the subjects that is being covered here, we will be having a next session on Docker, and the following session in 2 weeks on Kubernetes, and the third session, so fourth, early July, will be on Istio. So feel free to join us next week, and you will see in details some information about those systems. And if you are native to Silicon Valley, or you are here in the Bay Area, please come and see us at the workshops, at the lunch and learn sessions, and the meetups. We are often speaking South Bay and San Francisco. So why containers? Everyone loves containers, of course, and part of my family, I'm coming from the port city, who was involved in the bringing containers to my home country, Poland, and containers are great because they package everything inside, and they are having uniform interface outside. So you can standardize what is seen outside, despite the content is there. So like in the logistic industry, as you can see, large ships are moving around containers very easily. The same is happening with our systems. Little timeline. Everything started a long time ago before some of us thought about moving systems here and there. But real revolution started with the introduction of virtual machines. And myself, I remember using virtual machine in 2003, 2004. Before that, I had to change the disks in order to use other systems on my hardware. Since then, I could just copy over the VMs. And it grew very fast, very rapidly. 2008, we started to work on the various systems, and now we have prevailing ones, including Cloud Foundry that IBM Cloud is based on. We have Docker that IBM is also using, and Rocket. So what is the challenge? What is the problem, in fact? The problem is that we have a multiplicity of stacks. I am a Java developer, so usually I build Java-based systems, but people are building systems with Ruby, with Python, with Hadoop, with really various systems. And just recently we started to work with Swift systems, so iOS and Swift on the server side. So you can imagine all the various systems and how they are cooperate, how they are interacting with each other. So that's the one side of the problem. The other side of the problem is multiplicity of hardware and hardware environment. So you develop the system and you deploy it on the development via virtual machine. And then when you are ready, the machine, the system is supposed to be shipped to the quality assurance server. I remember that the difference between developing on Windows machine and then sending it over to quality assurance on the Unix system. And the Unix system was very small, and then we had to again ship it farther to the production servers that were clustered, and it was a completely different story. And we found a lot of errors just by moving things around. And nowadays you want to use and leverage cloud, and you want to leverage the resources coming from the cloud. So you rely on your internal systems, and you want to leverage the cloud. So you can find that there are a lot of things that are happening, and you would like to move your system, your application between various environments. So it comes the matrix from hell. So what you will do with static website, how you move it over between environments, and the same with the analytics DB, user DB, and so on. And all these systems need to traverse through various environments, from development to QA, then to testing, and then to the production. Then you want maybe deploy it also on the public cloud. So that's all very, very troublesome. But shipping container comes with the rescue for us, and the idea is great. You just package everything in the container, and container is being moved swiftly between the environments and in a uniform way. So you can on one hand, you can leverage your environment very quickly and deploy it in a container, package it in a nice way, so development can be done, and then operations can take over and place it through various environments. And I think that's the best comparison. One could argue that virtual machine is yet very similar. However, it isn't. In our case, virtual machine was also packaging entire guest system. So so you would create a system or so-called bare metal. So on the hardware, you would install the operating system. Then you would install the virtual machine hypervisor that is going to maintain all the machines and all the systems that are working. But you would have this huge overhead of the guest operating system. So on the left-hand side, you can see VMs that are very, very large installations. And myself, I remember reusing such machines. It was hard to even copy over 60 gigs of the system that was created just to entertain a database and some Java application that was living there. On other hand, you can start to think about containers. So they are having less overhead. They are just sharing with the host operating system the libraries and binaries that are key for running the system. So you can slim such systems. So comparisons are in even 100 times less than the same system you would create through the VM operations. And all these systems are running like previously we had a hypervisor. Over here we have Docker engine. So Docker engine is being deployed on the host systems and supervises activity and actions of the applications being deployed. So what concerns us and how comes the idea of DevOps? So development, so the part of the dev is intrigued and is using development, so is responsible for the code, for the libraries, for the configuration, for the runtime of the server itself and operating system. So this is the development that specifies the application. So that's the first part of the entire journey with the containers. Create the application, package it, and have it done for the runtime. However, operations comes as well. So DevOps, both parts, development and operations, are as important as the other one. So in operations, you take care of logging, access to the system from outside, so remote access. You configure your networking, how you access your system, and you can monitor your application. So these two separations of concerns, development and operations, are being merged together, and they are all treated the same way, with the same importance in our container. Advantages for the containers: they are portable. You can move them very easily between various platforms. So you can easily move them from Intel machines to the RISC machines. You can deploy them on the cloud, on various clouds. They provide you with just enough isolation. So there is very hard. They are usually stateless, so you don't bother an ephemeral. So you don't bother with more isolation than what we have already in containers. And containers, because of the way they are being built, they can be created in such a way that they can saturate in a positive way the system, so they can use the system more effectively, efficiently than the systems that were done with the approach of the virtual machines, or if you would install systems the old way, the applications the old way, you would install the server and then application. And containers are immutable. So you deliver your container and it leaves the same state through various environments. And here comes our little whale. So what about Docker? Docker is open software. So it's very important part. You are not locking in and you are achieving all the portability you want. You can have open contribution to the system. It's open design and open governance. So governance, people from various companies, various corporations, and open source, they govern development and next releases of the Docker. The most important part about Docker, or a standard way of working with the Docker, is build, ship, and run. So any application can run with these three words that define Docker mission. So you build, ship, and run, and it's being used for various systems. It's being implemented on various clouds. You can have it on IBM Cloud. You can have on other clouds as well. So you can run it on your own machine. My machine is running also Docker for Mac. You have Docker for Windows, and so on. So Docker components, it's an image. So it's a snapshot, read-only snapshot that you create, and you register under Docker Hub. And it's a template for building and next releases. So in the next webinar, we will go into details how you can create such an image. Then container, it's standard way that the application service is being transported and how the service is being represented. And then in the Docker Hub or registry, you can keep your resources. You can store and distribute your container images. So like IBM Cloud is having its own registry. Docker Hub is another place that you can store your images. And both of them are having a free tier that you can use as a developer on any of them. So our whale over here is just the basic image. And usually everything is done through these three stages. Docker Engine is the last part that creates, ships, and runs your application in a container on the physical machine, or sometimes it's even being deployed on the VMware to provide you with more isolation from the native system, but it's not important usually. So as I said, it's very important to see that everyone's journey starts with the one container that supports couple users. Usually one CPU machine can support in a web-based scenario about 1,000 users, about 1,000 concurrent users doing a search through your pages. But imagine if you grow, and if you want to grow, you have more containers to handle, and then suddenly the amount of containers grows very significantly, and it's overwhelming. So we step to the next phase, which is orchestration. And orchestration is just another way to make things work. And if you have a lot of containers, even in a shipping industry, in logistics, you can have some disasters like this on the Ital Florida Trieste ship, that containers were falling from the ship. So orchestration, so container engine is one part. So like a Docker is one of the container engines. Orchestration is another way to keep this at the base, so see how the systems are running. To have less headache, people created Cloud Foundry. So now you just step away from the system, step away from the providing yourself with the amount of the containers, and you just create a platform ready system. So that's Cloud Foundry. Or you can decide on the very specific applications, functions. You can go for serverless, and Apache is offering open source way to implement those on various systems, among them on IBM Cloud that is using Cloud Foundry. So OpenWhisk is the way to have a function as a service. Another way to get away from the challenge of maintaining a large amount of the containers. So orchestration means a little bit information like a conductor in the orchestra. You need to maintain all the containers, nodes that are being managed by you. You schedule systems to appear or disappear depending on the situation, and you have health management. Everything is done in coordinates with the image repository. So images are being pulled from the image repository, and you can use also Discovery DB for various things. If we look at the container layers, you would have the physical infrastructure, you would have a virtual infrastructure, and then operating systems. On top of them, you start to create the containers. So starting from the bottom, bare metal, then cloud systems, so like VMware or Amazon or IBM Cloud. Then on top of that, you have operating systems that you can leverage, Ubuntu, for example, for IBM Cloud, and then you would use container engine to launch your systems. And orchestration scheduling service is just the level of Kubernetes. And then on top of that, you would have the another system, so platform as a service, so like Cloud Foundry, so workflow to develop systems. Kubernetes is the most used system, so it's container orchestration. It manages applications, not hardware, and it's designed for being developed further. And it's open source project managed by Linux Foundation, and it's like everything. So you have to coordinate systems, who is coming and where they are going. If something breaks, then you use your team to engage. And if there is an emergency, you know what to do. A little bit about architecture. So from the registry, you would pull Docker images, and these Docker images would create pods in a worker node. So worker node would be the element that drives the specific pods, which are the elements in which you would package our containers. And then you would have various nodes that would be deployed or removed according to the rules that are being defined by the Kubernetes master that is being controlled by command line interface and user interface. So you'd have specific ways to manage your environment. And as I mentioned before, the basic kind of element of the system is container. So container is your application that can work with the other applications. So you have a container that is surrounded by the environment definition or unit of deployment, which is a pod. On the pod, you would deploy the container, and this pod would would be faced to the outside world or to the internal systems as a service. So it would be working together. And then on the worker node, you would deploy one or more pods that would consist of the system. So if you have a system of the login and a system of providing information, so probably you would have two pods running there. So deployment, it's, as I said, it's a set of pods that are going to be deployed together, and they are going into the they are going to be set for the next deploying. And when we deploy the application, if it crashes, it's being rolled back in such a way, and you can work with the various deployments. What I like about Kubernetes is all the abstraction layer, and we'll talk about that on the next slide. I mean, on the next webinar, which is going to take place in 2 weeks. So bear with me, and please be invited to come for the next meeting. So with Autoscale, we can have information about when it's a good time for autoscaling. So you can scale more pods in a horizontal way. So you can say, for example, CPU percentage saturation is about 50%. So you would need to keep that as a trigger for maximal deployment of 10 pods. And then if you want to use kind of a package manager, it's Helm. and you would define how to install and upgrade complex Kubernetes applications through Helm chart. So yet another markup language is being used. So files that are using spaces and a very simple text file, and that defines entire process. So as I said, Kubernetes is going to be our subject for the next slides, for the next webinar. In IBM Cloud, you can, as I said, you can deploy your Kubernetes clusters both in a public cloud, so the one that is being faced or deployed for everybody, and on the private one that is usually being maintained by the by various companies. However, the very good benefit of using it, it's on the cloud. IBM is providing machine learning and AI services that you can bind together with in the deployment of the containers with those services, the AI services or middleware and IoT services. So you can package everything together and deploy it together as well. If you want to take advantage of this course and try it out, please use the link that I'm providing for you below. So ibm.biz/containers, and it's June, so 06/19/18. So if you use this link, you can create your own account on IBM Cloud free of charge and try Kubernetes. So we have two options. One is cloud public and cloud private. The difference is that private is being operated for large corporations. Public is for everybody to use, and you can create your own stuff over there as well. However, private is having a dedicated hardware for the corporations. And when you deploy the application, the Kubernetes, you create a cluster. You have one cluster that is free of charge, and then if you want to move on, you can pay as you go for the next clusters. So, there are different options for the private deployment. We will talk about this during our talk on the Docker. So I will pass through that, but it's intriguing to see how you can use private installations. A little bit about Istio. That's going to be our last in this cycle of webinars subject. So Istio is the system to manage your deployments. So where Istio type of software finds its place, so it's intelligent routing and load balancing. So you know where requests are going through and where. It's enforcement of the policies. So that's also very important. So you have to check out, and you can provide resiliency and security, and you can add additional in-depth telemetry and reporting. So you have nice charts that are showing what is the health of your systems. And it's a little bit in this architecture that is being provided, that you can deploy applications and make sure that everything is working. So so we will talk about this in details on the last of our webinars in early July. And one more information about exchange and orchestration of the key and certificates between systems. So conclusions. Why containers? Industry is using containers, and because they offer a very uniform way to work with them. You can package whatever you want almost inside, and you can deploy them in various environments in a uniform way, so very simple way. So DevOps is one of the key aspects. We have Docker containers, one of the most popular containers out there, being used by various corporations, largest ones. Then you come into the challenge of the orchestration. So why why it's important to orchestrate them. When you have a lot of containers running, you want to have orchestration because you need to take into consideration all the systems that are running. Kubernetes is the way of orchestrating containers, and this is one of the ways that you can use. For example, in IBM Cloud, you can deploy larger implementation. And Istio comes as the intelligent or smart kind of orchestration and routing algorithm on top of it. It adds you a couple more metronomy and adds you some security support. As I said before, we have next sessions. Docker 101 would be on 25th. Kubernetes would be on July 3rd, and Istio would be on July 10th. So please, about the same time as now. So the last thing I wanted to mention is just the pattern. It's our Java-based code example, how you can deploy a very simple application. It's very well documented. So if you go to GitHub or our IBM page, you can go to developer.ibm.com/code and look for the patterns there. You should be able to see such pattern like shown here. And finally, we have resources, and on that, I would like to finish. We'll be sending to you all the resources, and please visit our San Francisco City events page. It's on developer.ibm.com, code, community, cities, and San Francisco. On that, I would like to thank you very much for staying with me, and I'm getting back to Maya.
Awesome, Mark. Thank you so much. So let us check out the Ask a Question section. Okay.
Questions.
Oh, where's the event taking place? Max answered that. Thank you, Max. Oh, it seems like Max has answered all of the questions. Thanks so much, Max. I think in the comments section, Mark, there's a question from Aaron Shen. Do you want to take that one on real quick?
In the comments section, Aaron Shen.
Yes. Could you elaborate the concept?
Okay. Could you elaborate the concept of pod? A given container is package of application. What does pod do for services or service as a unit of deployment beyond containers? So just to give you the idea, pod is the element that gives you the routing. So when you define the pod, it's like defining what container are you going to use. So pod is the basic element that gives you routing, gives you file system definition, so a little bit of the packaging style for Kubernetes. So you would not use it for the Docker. You would use it for Kubernetes. So Docker is using container, and this container now is being plugged into the larger entity, a little bit like a wrapper for system. What you can do also, you can add, for example, passwords and elements to this definition. So you can not only add the IP configuration, so networking, but also you can add some sidecar that would be defined to schedule, for example, database accesses and so on.
I think Casey.
We have one more question from Casey.
Yep.
That's a very, very good one. So I'm laughing because I have been with the Java industry for such a long time. I started 1996 with the work on the Java server side. It was very early development, and I stayed entire my career with Java. What containers is doing is packaging your application, and why you still have to develop your application. You still have to develop your code. So it's not about language, it's about the functionality. So in a container, you package more or less microservice, ephemeral system that does something. So if you want to achieve some results, you need to code them. And now comes the idea about Java Virtual Machine. Java Virtual Machine is great for deployment on various systems. It gives you abstraction layer. But when you have just one system in a Docker, it might be obsolete to use this pseudocode from Java to deploy it on various systems. Because you are going to deploy it only on the, for example, in the Docker, so it would use basic libraries. However, I think a lot of people still know Java for the industrial purposes, and I'm not seeing Java dying anytime soon. Can I get the copy of the slides? I think Maya is going to take care of that, and we'll have and I hope I answered both questions. So I invite you to join us for the next session. I will try to show you two things. One, how to create the pods and Kubernetes. It will be in July 3rd. But on the Docker session on 25th of June, we will be wrapping and containerizing application JPET store, so very well defined Java application. So I will show you step by step how to do it, and then we can continue our discussion if Java Virtual Machine is going to be there around us for the next couple dozen years.
Awesome. And if you have any specific questions for Marek, you can sign up for his office hours at ibm.biz/IBM CODE SF. And yes, thank you so much, everyone, for joining us, and we look forward to seeing you at our upcoming events. Thank you. Bye, everyone.
Thank you. Bye, everyone.